Hi, this is Karthik.
And this is Suchitra.
We are students of VIT University and this is a video about our final year project.
As engineers, we wish to work on a project that serves as a solution to problems that are faced on a day-to-day basis.
Studying in a university as big as VIT, we notice that there are a few problems which are faced by every educational institution, and we are going to address 3 of them.
The first one is the excessive wastage of electricity because of switching on of unwanted lights.
The second one is the lack of an efficient attendance system.
The third one is the extensive use of mobile phones by students during the class.
So how do we go about it? Let's take each of these problems one by one. How can we limit the wastage of electricity? It can be done by automating the light control.
Now, what do we need? A sensor that detects the presence of human being, an electromagnetic relay that acts as an electrical switch, and an interface between the two, that is a microcontroller.
The sensors that detect presence are called occupancy sensors. There are existing sensors like passive infrared sensor, ultrasound sensor, and microwave sensor. However, to make our system low cost, we shall not be using these.
We are using a combination of IR LEDs and photodiodes, which is popularly known as the IR sensor. The cost of these sensors is less than 50 rupees. The range of these sensors and their selective operability can be improved by placing them in a straight line opposite to each other as shown below.
If the classroom or lab happens to have computers, another way of detecting presence is by checking which computers are being used. This can be done by tapping connections from the USB port of CPU, which gives 5 volts in on condition. In case of classrooms with projectors, the switching on of projector must be accompanied by the switching off of certain lights. Pins 9 and 5 of the VGA pin, which are +5 and ground respectively, can be tapped for the same.
Coming to the relays, we've used relays with coil voltage of 5 volts that can be directly operated with the help of the microcontroller. The relays are equipped with optocouplers that aid in isolation of the DC circuit from any spikes in the AC circuit.
Now for the microcontroller that controls the relay operation, we have used Atmega 16A microcontroller because of its high performance, low power consumption, 32 programmable input-output pins, and 512 bytes of EEPROM which can be used to save data.
Do these work well for a real-time system? No. So what are the problems that you would face? Laying DC wires along with AC wires could result in coupling and induce noise. Shielded cables should be used to prevent this. Also, there will be a potential drop because of the resistance, which can be fixed using op-amps.
What if there is a power loss? We could use a battery for backup, but they need to be replaced time and again. So we go for a capacitor bank which is capable of supplying power for a fixed time period. The proposed system was implemented in the software laboratory of EDC Research Lab under the School of Electrical Engineering. The IR sensors were installed in the rows, and in places where they could not be installed, the USB connections from the CPUs were used. The control box was placed near the AC switch terminals and the relays were connected in parallel to the manual switches such that the existing system remained undisturbed.
This is a demonstration of the light control system. The microcontroller counts the number of students in each row and turns on the respective lights, and also as they move out, it turns them off. A delay of 5 seconds is added between the switching operation of the lights. The switching on of the projector is accompanied by the switching off of the light right above it. Lastly, in rows installed with the USB connectors, switching on of the computers results in turning on of the respective lights and vice versa. The design can be improvised by use of neural networks with a compromise in the cost. The implementation can be extended to offices, megastores, and libraries.
Moving on, the second common problem is the lack of an efficient attendance system. We have the barcode ID scanner, RFID scanner, biometric recognition, and face recognition techniques as existing solutions. We have preferred to use the object character recognition method.
So how does OCR work? In layman's language, capture an image, crop out the portion containing the text, and convert from image to text by comparing with pre-recorded patterns. So you may ask why OCR? The advantages of OCR is its versatile nature, that is, it can be used to read barcodes as well. So what do we need? A simple VGA webcam to capture the snapshots, an image processing software to process the snapshot, which in our case will be MATLAB, and a physical setup which is user-friendly to carry this out.
The setup consists of a 16x2 LCD screen, a slot for placing ID card, and sensors to detect if the ID card is placed properly or not. It also has a microcontroller and a web camera. The microcontroller is used to monitoring the sensors, interfacing the LCD, and serial communication between the setup and the computer. A GUI using MATLAB was also built to enable users to use it more conveniently. The application was compiled using MATLAB 2014 compiler, which eliminates the need of MATLAB in user's PC. Once the automatic attendance is switched on, serial communication takes place between the module and GUI. When the ID card is placed properly, MATLAB takes a snapshot, recognizes the registration number, and displays it on the LCD. Registration number will be stored and can also be viewed. At the end of the class, the teacher can send the list to his or her email ID with the option provided in the GUI. A faculty database is also added dynamically for the future use. Such a system again could find its application in offices, libraries, megastores, apart from educational institutions.
Now finally, the third problem. How do we monitor the mobile usage? One of the best ways is to make an Android app for the same. Such an app can also be used to give attendance. The launcher activity allows the student to enter the registration number, which gives an error if invalid registration number is entered. Once a valid registration number is entered, it can be saved for all future sessions. The student must start the session to give attendance, and throughout the session, if he or she tries to use the phone, it will be recorded. At the end of the session, the student must stop the session, and the summary of the class can be uploaded to the FTP server through Wi-Fi connectivity. The summary can include the registration number, start time, stop time, and phone usage details. However, the application should allow the user to lock and unlock the phone without minimizing the app. This application has numerous future prospects like restricting the use of few apps, monitoring the use of particular applications, and even using it as an educational aid.
We would like to thank our guide for his exemplary guidance and our dean for his support throughout the course of this project.
A special thanks to the School of Electrical Engineering and the VIT University Management for supporting us in this endeavor. Hope you enjoyed our video. Thank you.